Let's continue with the topic called stoichiometric and its stoichiometric calculations. So what is that stoichiometric means? It does that. It is a branch of chemistry that deals with the study of the relative quantities of reactants and products in a chemical reaction. Or else I can tell that, so it is the study of a chemical reaction and calculation related to it. So that is called stoichiometric. So here one word comes, that is called chemical reaction. So here one word comes, exists, that is the chemical reaction. What do you mean by chemical reaction? So let us define first one to understand this topic. So if I take this example, you know that this is a reaction. It is an example for reaction. Or else I go for a very basic, that is A2 plus B2, that gives rise to 2 times of Ab, right? How it is formed here? A2 I am going to write as it is. This is called A2, I mean bond between the two atoms, and this is called B2. So what we are going to get? We are going to obtain the different atoms combination. So like this. So here what happens? The chemical reaction, what it does that? It is a rearrangement of atoms. That is called rearrangement. Here the breakdown, the bond will break down here, and here also break down. I mean rearrangement. The rearrangement atoms of various molecules of reactants that gives the various molecules of the products. I mean the bond is breakdown, and this A, this B combined to make a one bond formation, and this A and this B combined to make one bond formation. So that is called chemical reaction. It is a rearrangement of the atoms of various molecules in a reactants to a various product. So that is called chemical reaction, and this is also an example for the chemical reaction. Stoichiometry is mainly founded on the basis law of conservation of mass. So actually what do you mean by this law of conservation of mass? It tells that whenever in a reaction the mass of the reactant that must be equal to the mass of the product. So if I take this example, so this portion is called reactant and this is called product. Okay. Now I am going to apply the conservation of mass, because this stoichiometry is mainly based on this law only. So what it does, the reactants of the mass that should be equal to the mass of the product. So here if you take the magnesium, how many magnesium? 2 atoms are there, and its atomic mass is 24. So here 2 atoms will be there, that becomes 48, right? That becomes 48 plus oxygen atomic mass is 16. So here 2 molecule is there, it's a doubling. So that is called 32. So and right side I am going to write as 80. That must be 80. When you add this one, 8 to 10, 8 to, that is 48 plus 32, it gives us to 80. So when you add these atomic masses of these atoms, then you are going to get a 80. I mean the law of conservation of mass, it tells that the mass of the reactant that must be equal to mass of the product. So that is based on this conservation of mass. Every reaction setup will be takes place like this only. This equation implies that 2 moles of magnesium which combine with 1 mole of oxygen molecule, it gives rise to 2 moles of the magnesium oxide. 2 gram of magnesium atom which is going to combine with the 2 gram of oxygen atom to give a 2 gram of the compound, that is called magnesium oxide. So if I tell in the mass, what happens? So here the 48 gram of this magnesium atom which is going to combine with the 32 gram of the oxygen atom which is going to give 80 gram of the molecule, like this. If we take this reaction, nitrogen gas which is going to combine with the hydrogen gas to form the molecule of the ammonia. So now look at this reaction. So whether it is balanced or not. So here 2 nitrogen, here 1 nitrogen, and here hydrogen, and here 3 hydrogen. 2 hydrogen, 3 hydrogen. Then according to the law of conservation of mass, this reaction is not going to be satisfied, because it tells that the mass of the reactant that must be equal to the mass of the product. But it is not following, right? So we are going to balance it. How we are going to balance this one? So here the nitrogen gas, 2 nitrogen will be there, and here single nitrogen will be there. So I am going to multiply with here, then it becomes 2n, and this is 2n. Now dissatisfied. Next we can see here hydrogen. So here 2 hydrogen, here 6 hydrogen. So I am writing as 3 hydrogen molecules. So like this. So So now it is balanced. One molecule of N2 and 3 molecules of hydrogen, it gives rise to 2 molecules of the ammonia. So now it is going to be satisfied according to the law of conservation of mass, or also we can tell that mass can neither be created nor be destroyed. So what are these numbers? So in order to maintain this, in order to balance this reaction, I am going to write these numbers. So what are these numbers? These numbers I am going to call as stoichiometric numbers. These are numbers called as stoichiometric numbers. So according to the definition, stoichiometric numbers are the numbers, these numbers of the molecules which is going to participate in a several reaction or various types of the chemical reaction. So let me show you how to represent the stoichiometric in different words, in different many ways. Okay, so first it is the setup of the reaction. You know that this is the nitrogen, hydrogen, which is going to combine with the molecule, and this process is also called as Haber's process. Haber's process means we are going to produce in the ammonia. So this name is called Haber's process. So in this reaction, everything is balanced, right? So one molecule of nitrogen, 3 molecules of hydrogen, and it gives rise to 2 molecules of the ammonia. So in stoichiometric, everything is balanced right now. So here we are going to particular names will be there in terms of molecules, in terms of atoms, in terms of mass, in terms of mole. How we are going to represent the reaction, that is very important. That is called stoichiometric reactions and stoichiometric calculations. So everything is set up based on the conservation of the mass. So first we take in terms of the molecule. How many molecules are there? So that is called one molecule of this nitrogen, which is going to combine with 3 molecules of hydrogen, that gives rise to product as 2 molecules of the ammonia. This is called as the stoichiometric word representation. If I go to doubling, if it contains one molecule, then it is in the ratio as 1:3, right? So if I take doubling this one, what happens? If 2 molecules of nitrogen, if I write here, then automatically this is the ratio also doubling, right? Then it becomes 3 to 6. 6 times of this hydrogen molecule, which is going to combining to the product as here 2 is there. So when I doubling the reaction of the reactants, then the product must be also doubling. So that's why it is 4 molecules of the ammonia we are going to form here. So let's come to these are the terms in the particular terms in the molecules. If I take the Avogadro number, what do you mean by Avogadro number? So that value is nothing but 6.023 into 10 raised to 23 atoms or molecules. Anything you can tell. So this is called Avogadro number. So if I take one Avogadro number of the molecule of this nitrogen, one Avogadro molecule of the nitrogen, then according to the ratio, then it becomes 3 Avogadro molecules of the hydrogen, which is going to combine to give the product as 2 Avogadro number of the molecule of the ammonia, like this in different words. And also you know that one mole is equal to Avogadro number. Avogadro number is equal to 1 mole. So if I write in the Avogadro number, I can write also in mole. So here Avogadro number of the nitrogen means then it becomes 1 mole. So that's why its name is 1 mole of nitrogen, which is going to combine with the 3 mole of the hydrogen, that gives us to 2 mole of the ammonia. Or else in terms of atoms, so how many atoms are there in reactant nitrogen? So that contains the 2 atoms of the nitrogen, and how many will be there here? 6 atoms of the hydrogen, because if you split into hydrogen 3 times gas, H2 plus H2 plus H2, then it becomes 6 atoms of the hydrogen, that gives rise to in the product as 2 atoms of the nitrogen. That is, you should see the link with the reactant and product. So in the product I written 2 atoms of nitrogen, that is also available in reactant, and also 6 atoms of the hydrogen, 6 atoms of the hydrogen. So in terms of atoms also we can define this stoichiometry. And last come to the mass and its mass. You know that this nitrogen, its atomic mass is 7, so its atomic mass is 14. 2 atoms will be there, then it becomes 28 gram of nitrogen, which is going to combine with the hydrogen. Hydrogen is 6 gram of hydrogen. Each hydrogen contains 1, its atomic mass, then it becomes 6 times 6 gram of the hydrogen, that gives rise to 34 gram of the ammonia. Means when you are going to count this atomic masses, we are going to get the 34 gram of the ammonia. So like this, in different many particular words, we are going to define this stoichiometric. Calculate the mass of the water formed when 100 gram of oxygen that is going to burn in the oxygen. We should calculate the mass of the water, how it should be. Okay, let's see here. First we should take the reaction. First we should write the reaction. what it tells, hydrogen is burnt in oxygen. So first is hydrogen that is going to burn in the oxygen that gives rise to water molecule, right? So first we should write the reaction. Then our first aim is to find out the balanced chemical equation. What do you mean by balanced chemical equation? So LHS and RHS, that atoms should be same number of atoms of the reactants that must be equal to the same numbers of the atoms in the product side. So you see here S2 and S2 is balanced, and here O2 and here only single oxygen is there. So what I have to do, I want to multiply here 2, then it becomes O2 is matched, and here 4 hydrogen, that I should write 2 hydrogen. So our first aim is to balance the chemical reaction according to the law of conservation of mass. Then what is our second step? Second step, we should write the molecular mass of the respective elements. So suppose if I take this hydrogen, if you give this coefficient, I mean stoichiometric number, so hydrogen that becomes 2 gram, right? 2 gram of the hydrogen. So 2 into 2 gram of hydrogen plus, which is going to combine with 1 oxygen, atomic mass is 16. So here 32 because 2 oxygen, 32 gram of oxygen that gives rise to water molecule, that is called, one water molecule is 18, it contains the 18 gram, here 2 will be there, 2 into 18 gram of the water. Our next third step is we should calculate the quantities of the reactants and products. Suppose, so our aim is to find out calculate the mass of the water formed when 100 gram of the hydrogen is burnt in the oxygen. Suppose now I am going to multiply this one because the quantities I am going to multiply here, that becomes 4 gram of hydrogen, which is going to give the product as 2 into 18, that is called 36 gram of the water. And what they are going to ask? Calculate the mass of the water formed when 100 gram of hydrogen, that is 4 gram of hydrogen that gives rise to 36 gram of water, then 100 gram of hydrogen that gives how much? Then you are going to multiply, cross multiplication, that is 36 into 100 divided by 4. That is nothing but you are going to obtain the 900 gram of the water. 900 gram of the water. We got the 900 gram of water that is formed when 100 gram of hydrogen that is burnt in the oxygen. So this is our answer. Next we can see very interesting problem. So that he is going to ask how many moles of propane that are required to produce the 22 gram of carbon dioxide after combustion. So he is going to ask the propane. You know that propane, you have studied in your basic classes. Propane is nothing but 3 carbon. So we should find first what is the formula of the alkane. So alkane formula is CnH2n plus 2. So he is asked propane. Propane means 3 carbon atoms. Butane means 4 carbon atoms. Pentane 5 carbon atoms. Here propane he has asked. So you should substitute the value of n is equal to 3. C3 and H2 into 3 plus 2. So that gives rise to C3H8. So that is the formula of the propane is called C3H8. So our first time we should write the reaction. So this he is going to ask the propane are required to produce the 22 gram of the carbon dioxide. Then what is our product? Product is called carbon dioxide. And the equation is so this is the equation. Okay. So propane which is going to combustion combining with oxygen which is going to form the carbon dioxide and respective water molecules. So we should see the whether atoms are correct in form according to conservation of mass of C. So C3 will be there. So here carbon will be there. So 1 carbon. So that I am going to multiply here. So 3 carbon. Now it is balanced. So now it becomes 6 oxygen. 3 to the 6 oxygen. And here total 7 oxygen, right? 7 oxygen. And here 8 hydrogen will be there. Here only 2 hydrogen will be there. So I am going to multiply with 4 hydrogen, right? So 4 to the 8 hydrogen. And here oxygen. so oxygen becomes 3 to the 6. 3 to the 6 oxygen plus 4 oxygen, then it becomes 10 oxygen. Now I am going to write as a 5 molecules of the oxygen. So now the balance is right. So C3, so first I write the stoichiometric coefficient or number 3C first. So now balance it, and also here hydrogen 8 will be there. Here only it was only 2 hydrogen will be there. So that's why I am going to multiply with 4. Now it becomes 8. Hydrogen is balanced. Only we should balance oxygen. So you should count here 4 oxygen plus 3 to the 6 oxygen, that gives rise to 10 oxygen. So already O2 will be there. I am going to multiply with 5 oxygen. So this is our first step. We should write the chemical reaction, and also we should go to balance this equation. What is our second step? Second step, we should write the molecular masses of the respective molecules. So how many molecules will be there? C3H8. I written the atomic masses of the respective. So carbon will be 3. So that is 12 3 36 plus hydrogen 8. 8 means 1. 8 plus that gives us to 44 gram of this propane, and oxygen is how many will be there? Oxygen 16, right? So 16. So how much it becomes? 32 into 5. We should multiply this one, and also 3 carbon dioxide, it gives us to 132 gram. That gives us to 132 gram. So this is not needed for this one. I am going to directly for the third step. What you should take down the quantities. Quantities are very important. So he is going to ask how many moles of the propane are required. First we should see here. This is called one number. I mean 1 moles of propane, which is going to produce as 3 moles of the carbon dioxide. According to question, first 1 mole of this methane, which is going to give rise to 3 mole of the carbon dioxide. Our question is asked how many moles of propane are required to produce the 22 gram of the carbon dioxide. So here question mark. So what we are going to do? We are going to cross multiplication with this one. Then it becomes into, see here 3 here carbon dioxide. How much? That is 44 gram of the carbon dioxide. 44 gram of the carbon dioxide, because 22 gram of this carbon dioxide into 1 moles of propane contains the 44 gram divided by the 3 moles of the carbon dioxide. That is 3 into, what is the carbon dioxide here? So that is 44. So we should calculate this one. So after this calculation, we are going to get the value as 7.38 moles. 7.38 moles. I mean, so 7.38 moles of an propane, which is going to require to produce the 22 gram of the carbon dioxide after combustion. So once again, first you should write the reaction, and that should be the reaction also balanced manner. So this is the balanced, and our second step is we should write the molecular masses of the respective compounds, which is going to ask in question. So it is the matter of the propane and only matter of the carbon dioxide. So we should write the first molecular mass of this propane. So propane C3H8. So that after this values, when you multiply, we are going to get the 44 gram of this propane, and this is carbon dioxide. What is the molecular mass of the carbon dioxide? That gives us to 44 of the carbon dioxide, and here 44 into 3, we are going to get the value as 132 gram of this carbon dioxide, or simply you can write 3 into 44. I have written like this, 3 into 44, like this you can keep here. And our third step is, come to the question. He is asking that, first you should see, this is called 1 moles. 1 moles of propane, that is gives rise to 3 moles of the carbon dioxide, right? How many moles of the propane, required to produce the 22 gram of the carbon dioxide? So when you cross multiplication with this one, so 22 into, that is what is the molecular mass of the propane? That is 44. 22 into 44 divided by 3 moles of carbon dioxide. 3 into 44. After this calculation, so we are going to get the 7.38 moles of the propane, which is going to require to produce the 22 gram of the carbon dioxide.